welcome to No Physics with me. Hope all are doing good. Yes, so we have started with Physics CBSE class 10, chapter 10, light, reflection and refraction, and we are almost towards the end of the lesson, right? So previous session we saw image formation in spherical lenses for using ray diagram, and we have seen for both concave as well as convex lens, and in this session we are going to cover sign convention and magnification for lenses. If possible, we will cover power of lens also in this session, and we will end up with this video, okay, of the entire chapter. And in next sessions we will look up for the problems to be solved. Either one by one we will solve in separate videos, or together we will try to solve it in a single video. Clear? Yes. So the topic today we are going to cover is sign convention for spherical lenses. So I hope you are all thorough with sign convention for spherical mirrors, right? Then this is very easy actually, and this is one of the most important topic for this chapter because numericals are based on sign convention only. So only when you have correct sign convention you will get the right answer. Okay, so listen to this carefully. Just like mirrors, the terms are same. Okay, so U stands for object distance, V stands for image distance, HI stands for height of image, and H naught stands for height of object. And we do have F and C, which is focal length and center of curvature, right? So instead of center of curvature, here we will have it as 2F. Yes or no? Yes. So object distance, irrespective of whether it is lens or mirror, your object distance will be always negative. It is because, consider this, okay? This is your convex lens. Yes or no? Yes. So mark the points. So you will have a clear-cut idea. Here it is O. Where you place the object every time? Left hand side of the lens, right? So always your object distance will be negative for both mirrors as well as lens. And similarly, height of object. Anyway, you are going to place it here only. Okay. So this is Y, Y dash, X, X dash. Clear? Yes. So always you will place above the principal axis only your object. Yes or no? So always your height of the object will be positive. Object, it will remain the same. For both lens and mirrors, your object height and image distance, object distance will be same. Object distance will be negative and object height will be positive. Now, image distance. Image distance for 5 cases it will be same, and for the last case alone it will be different. Okay, your image, where your image will be formed? It will formed on the right hand side, right? For first 5 cases the image will be formed on right hand side, which is real and inverted. Okay, so your image distance will be positive, whereas it was negative for mirrors. Here it is positive. Okay, because the image is formed on your right hand side. And height of image. So for the first 5 cases, your image will be real and inverted, right? Inverted means here only your image will be formed, and along Y dash, right? So it will be negative for the first 5 cases. Last case alone, there is a difference. Here you will get virtual and direct. Virtual and direct means it will be on the same side as that of the object, right? So in that case, you will have a direct image along Y axis. So the height of the image will be positive only for one case. Remaining 5 cases, it will be negative. Clear? That between the point F1 and O alone, it will be positive. Positive. All the other 5 cases it will be negative. Clear? Whereas image distance will be positive for the first 5 cases, and the image distance will be negative for the last case, that is between F1 and O, because where the image is formed, it is formed on the same side, right? On the same side as that of the object. So it will be negative. Negative for one case and positive for 5 cases. Clear? You're clear with this? First of all, what you have to do is, before going for sign convention, just note U, V, H, A, H naught. F and C, okay? It's even okay. U, V, H, A, H naught, you should be very careful. Okay? So, U will always be negative and H naught will always be positive. Okay? For both mirrors and lens. And V and HI will differ based on the cases. So, we have seen for convex lens. Now, we'll go for concave lens. Clear? Yes. So, first thing you have to do is, when you get a sign convention, draw basic diagram. Just like this, draw the diagram. So, you'll have a clear and correct understanding of sign convention for both lens and mirrors. Clear? Yes. Similarly, for focal length and center of curvature, that is 2F. Okay. This one, it will be positive for all the cases, all the 5 cases. And for the last one alone, it will be negative because it is falling on the same side, right? So, in that case alone, it will be negative. For all the 5 cases, it will be positive. Clear? Yes. So, now we will go for concave lens. Okay, so for concave lens, your object distance will be negative. For whatever lens or mirror, your object distance will be negative and height of object will be positive. Clear? And focal length and center of curvature. So, where we will use? We will use on this side only, right? So, it will be both negative in for both the cases. Okay? And your image distance. Your image distance in both the cases we will get virtual and direct image and on the same side, right? So, your image distance will be negative for both the cases in case of concave lens. And what about your height of image? You are getting both the cases as virtual and direct. So, it will be along y-axis which is positive. Clear? So, your object distance will be negative, your object height will be positive, and for both the cases it is same. Image distance is negative, image height is positive, and focal length and center of curvature, it will fall on the same side. That is why we are giving it as negative. Clear? So, this is what the sign convention. So, next is lens formula. I hope you are all clear with sign convention, right? Yes. Now, it is lens formula. So, just like mirror formula, we have lens formula which is connecting focal length and image distance and object distance. So, there is a small difference in sign except that both are same. 1 by F is equal to 1 by B minus 1 by U is the lens formula. So, for mirror formula, we have the same except the sign here it is plus, here it is minus. So, 1 by focal length is equal to 1 by image distance minus 1 by object distance. Clear? Yes. So, this is what the lens formula is. Then we have something called magnification which we gave detailed explanation for mirror. So, the same applies for here. So, here magnification M is equal to Hi by H naught which is equal to V by U. So, when you have questions related to magnification, the formula is Hi by H naught which is equal to V by U. That is, when you have magnification and height of image, you can find the height of the object using this formula. If based on distance they have given, you can use M is equal to V by U. So, any formula you can use, substitute the values and find the answer. So, magnification is nothing but when you compare it with object size, how is your image size? It is lesser than the object size by what ratio? So, this is what we are going to understand by the term magnification. Clear? Yes. So, magnification for mirror it was minus V by U. Here it is V by U. That is the difference for mirror and lens. Clear? Yes. So, the last topic of this lesson is power of lens. So, one of the important topic, we do have numericals based on this. So, it is one of the important topic that we have to understand because we are using it in daily life. So, what this lens do with this light rays? It either converges or diverges, right? Yes. So, the ability of the lens to diverge or converge the light rays falling on it based on its focal length is nothing but called as power of lens. You are able to understand, right? So, lens, what does lens do? Lens either converges. Convex lens converges light and concave lens diverges light, right? So, the ability of the lens for convergence and divergence of light rays falling on it based on its focal length is called as power of lens. So, we will represent power of lens as inversely proportional to focal length. You understand? So, in convex lens, it converges and brings to a point near to optic center. Whereas in concave lens, it diverges. Correct? So, based on focal length, we can decide the power of a lens. You understand? Yes. So, it is inversely proportional to focal length. So, focal length is measured in meters and power is measured by a unit called diopter. D. Okay, so it can be represented by the letter D. D means diopter and focal length is measured in meters. Okay, so understand one more thing, concave lens and convex lens. When a doctor prescribes a power of minus negative, it means he is prescribing concave lens. Whereas if he is prescribing a power of positive plus, it means convex lens. Okay. Now, how you can calculate the power of a lens? Using the focal length. Say your focal length is 50 meters. So, find the power. Power is inversely proportional to focal length. So, P is equal to 1 by F. So, P is equal to 1 by 50. Clear? So 1 by 50 you have to do and find the answer and write the answer as that much diopter. Clear? 1 by 50 diopter. Suppose your question might contain focal length in centimeter. In that case you have to convert that into meter and find the power. Clear? So concave lens. Generally most of the people are using concave lens because they have negative power. That is they are not able to see distant objects. Right? And convex lens, nearby objects they are not able to see it clearly. In that case they will use positive power. So I hope you are all clear with what is power of lens. Yes. So by this we are going to end this lesson and in next sessions we will follow numericals based on this and also booking questions as well as book back questions. Okay. So I hope you are all clear with the topics discussed entirely from session 1 till now. So if you have any doubts, kindly post your questions on the comment box. Okay. So if you like the video, do share it with your friends. Do subscribe my channel. So for previous videos, any of the video if you want to watch, I'll provide you the link in the description box. Okay. Check to it. Okay. So thank you for watching this video. Thank you for all the support given. Keep supporting. So thank you.